Today we will discuss how to make an automated design using AutoGen's version 8i. To do that, we will use an option inside AutoGems. It's called Darwin Designer. Open Analysis table and click Darwin Designer. It will open the order. Darwin Designer simplifies the design process by allowing you to run manual or optimized designs for your system. It has 5 steps. First one, click on the drop down menu to use the table that appear across the top. 3. Add a manual or optimized design run. 4. Click computer run to run your design and assess how it fares against host terrains. 5. When you have a design you like, you can export to a new scenario. But to do that, I will not do it on one scenario. Okay? Why? As the existing scenario is for 2010. So I will not design for this stage, for this period right now. And there are a very important note. In Darwin Designer we will make 2 design events, as there are 2 networks, 2 existing networks, one for Zilzal and the other for 70 feet. To make automated design using AutoGens, we must have 5 scenarios for designing. First one, 2010, then 2020, third, 2030, fourth, 2040, and 2050. So I will use the required discharge for the 5 period intervals in order to get the most optimized design for the network for Zilzal and 70 feet networks. Why? As by the time the efficiency of the network change and decrease by the time due to the corrosion of the system, aging of system parts. If you, for an example, if you open report and opening the pipe table, you will see Hazen William coefficient is 130 as it is a new, and the material which will be used for design the pipeline system is cast iron. This number will be decreased by the time. That will lead to high heat loss due to the increase of friction inside pipelines. For logic, in any design we use the maximum required discharge. In this case is at 2030, and check for the other criteria or the other scenarios for 4 other periods intervals: 2010, 2020, 2040, 2050. But that's very wrong. Why? We will discuss that, but first we must add or define the five scenarios. You can choose scenario from the scenario button or from analysis to create other scenario. 2020, 2030, base scenario 2040, another base scenario 2050. Then we will go to alternatives to create for every scenario its alternatives. I have it already created, but I will recreate it again to learn you how to create an a new alternative. The existing alternative is available that for 2010. Click other scenario and begin to create alternatives. Our interest will be for physical and demand. I will create physical alternative. Will I name it 2020? The base physical will I name it 2010. 2030, 2040, finally 2050. Then creating for demand. First one called 2010. If I click new, it will create sub alternatives, and that is wrong. So every time to create alternative, I must click on the main alternative category 2020, name it 2030, 2040, 2050. We will need to create other alternatives, but the most important is for physical and demand at this stage. After that, we will create for each operational and fire flow beside flashing. First one for 2010, I will create the Hamiltonian coefficient. We'll make it 130. For other period, I need the table which describe the Hamiltonian coefficient by the time. As you know, the increase of the age of the system lead to the decrease of Hamiltonian coefficient, and that lead to increase the heat loss coefficients. Here is the table for the C factors for cast iron. The U for all sizes 130. After 10 years, I will set it 100 by getting global 8 110. 20 years will make it 95 as an average. So 2030 global edit, writing it 95. After 30 years we'll make it 85. At 2040 global edit or 80. After 40 years at 25 I will make it 70 or 75. Now I created all Hazen-Williams coefficient which changed all over the time. After that we need to set the month for every period. To do that I can choose from the month and create every junction the month, but that will take more time to recalculate every junction alone. So go to 2010 and create every alternative for every time period. For 2020 choose 2020 in physical and demand. Also for 2030 choose 2030 classification for physical and demand. 2040 2. Finally 2050 for other, as I told you before, will be changed due to the scenario requirements, but after making the steady state and extended period simulation analysis. Now, after preparing alternatives, each alternative is ready for editing it. First, we must confirm about the demand, the required demand at each junction. Take a copy of it, move it to demand Excel, which we used to create the required demand for 2010. I will create other columns. Population at 2020 will multiply the number of unit demands at 2010 by the factor of population increase. Clicking unit demand, you will note that at 2020 there are no demands, so I must create it by clicking selection set, which I prepared before for the different elements. Click the then junctions. Okay, set it 0 at first. After that we will create it by recalculating the required demand at 2020. I need the required supply calculations table and open calculator from Windows. Now I will divide the required population from 2020 by the population of 2010, getting the population increase factor, setting it there. After that, make a formula by multiplying the numbers at e columns in the factor. Autofill will get the required uh, number of unit demands based inside the unit demand global edit, set the required unit liters per capita per day for unit demand as 2020. It will calculate it automatically. Add demands. Now we will add 70 feet and junctions and its required demands. I will repeat that with the other period intervals. After creating the 5 scenarios with its alternatives, now I can use Darwin Designer. I will create 5 new design cases for every period interval 20 to 10, 20, 20. 2030, creating 2040, and creating 2050. I will create for every Darwin Designer study 2 events, but first let's discover the table. First, design events for making design events, design groups for creating the required pipeline to design. First, I will create the scenario for 2030, 2020, 2040, 2050, each one for each scenario. I'll confirm that. After that, we'll create or discover the table design events that consist of elements, boundary overrides, demands, ethic, design groups for creating the required pipeline to design. Rehabilitation groups, if I will rehabilitate the network or some elements inside old network. Possible properties to create the bias list for new system or for rehabilitation. Design type, for creating the conditions for designing by choosing 3 options. First one, minimize cost, maximize benefits, it have available budget and benefit coefficients. I will use minimize cost. There are multi-objectives. For creating the pressure benefit coefficient and the pressure benefit exponent, dimensionless or unitized. Notes, to write notes about the design criteria. At design events for 2010, I will create 2 design events, not 1. Why? As I have mentioned that before, I have 2 networks. So 2 separate networks, that means I must create 2 design events, not a design event criteria. Okay, the 2 networks are not connected together. Everyone is a separated network. So back to Darwin Designer tool. We'll create another new design event also for the other design intervals criteria. Now I will assign the design limits For maximum pressure, I don't care about it, so I will put it 200 head. For the minimum pressure due to the Egyptian codes is 2050 meter. Minimum velocity, I will set it quarter meter of second. Maximum velocity, I will set it 1 and a quarter. The maximum velocity is 20.5, 2.5 by dividing it by 1.3, as 1.3 is the maximum required discharge at the highest water consumption needed for 1 hour. I will set it also 25 at least quarter meter per second as a minimum velocity, and the maximum I will set it 1.8. Now that's time to set pressure constraints for specified junctions which supply the system by the demand. Okay, I will choose first zilzal junctions for first designed event. For the second, I will choose 70 feeder junctions. For flow constraints, we'll use also design network. For the second design event, we'll choose 70 feeder network. Now I will create new optimized on or new optimized designer. For design events, it has 2. For design groups, it didn't set it. Why? As I forgot to assign the design groups, I will set all available elements if I need, or for a specified selection set like design network, but the design groups includes all design events, so I will select all available or select the 2 selection sets for the 2 network. Addition groups I don't read. Cost properties, I will click design option groups for make a price list that the software will use to design the system. Consists from 4 row or 4 columns: material, diameter, Hazen William, C factor, and unit cost. As I'm from Egypt, the unit cost is Egyptian livre. For a diameter 200 millimeter, I will use the Hazen-Williams coefficient, as the system at 2010 is a new system. must create the table manually as it doesn't accept global edit option. Diameter 300 millimeters, 400, 50, 500, 600, 700, 800, 430, 150 Egyptian lev, 40, 20, 220, 500 millimeters, 35, 50, 350, 460, 580, and finally 70. Design type, I will use minimize cost. For new, when done in design groups, I must select cost properties, global edit, set it new pipe 3. I will change it by rename it to 2010. Sorry, 2010. After that, everything is okay. I will click compute, show me design and calculation failed. Why? I will know the reason. The pump definition isn't selected or defined for the element. So I will redefine it again. Choosing the zilzal, pump definitions. I must confirm that all system components are defined. Note that all pump was set for definition to 0, so I will use the selection set to define them all. Edit group, choosing the pump table, add pump definition, click global edit, set them all to the result pump definition. There are missing one, so I will add it to the selection set. We'll choose the zigzag bumps. Okay. Clicking on the zigzag bumps and click edit group, pump table, set definition to all zigzag. The same I will do for 70 feeder pump. From view, click selection sets, 70 feeder pumps. Right click and edit group, pump table. Okay. Also, I will do that for the elements in the different design periods. When connecting board junctions, you will note that all elements have zero at elevation, zero values at elevation. So the elevations are not set. What to do? To do that, or the order to do, you must define the elevation for all missed junctions in other scenario. To do that, I must return to scenario 2010 and uh, sort junctions label to ascending, copy the elevation column, go to other scenarios and just paste it. I will repeat that for all scenarios, defining all missing elevations for other elements. I will repeat that with all junction to make the 5 scenarios ready for analyze. After that, the system will be ready for using Darwin Designer option. After calculating again, it has designer field notice. Pipe has not a defined diameter, as the diameter is set to be 0. That not acceptable for the software, so I will set it at any number or at any diameter. After calculating it, finally Darwin Designer tool for 2010 is working. Now we evaluate the optimized solution. It has only one solution. We'll check it. The maximum cost 10 million. Thus, we'll check simulated pressure. Also simulated velocity. I don't care about the velocity less than quarter meter per second. It is not important, but which I care is the velocity which exceeds 1.8 meter per second. There are 4 pipes, so I will redefine them after take all solutions and applying it inside the scenario. The second part of the video, I will explain the other Darwin Designer studies for 2020, 2030, 2040, 2050. So after that we will use the best or the most optimized one to set it inside the network.